Hello, Chem 2 students. Mr. Keister here with you again today. This is the video for Friday, October 23rd, 2020, which is our scheduled 45th day of school for the fall semester. Always keep in mind, though, that the dates could change for a variety of reasons, but the lessons in the order that those lessons are presented will remain the same regardless. So let's take a look at the schedule and see what our do nows have to say for the day. So today you're going to pick up Lab 3.2. We're going to do that first. Shouldn't take too terribly long. And then you can spend the rest of the time working on your review. We have a test coming up soon, so that needs to be done as well. So your homework for today was to complete the ion formation assignment. You can hang on to that. Please check your answers, though. They're posted on the backboard, and of course, they're also posted on the answer keys page in Canvas. That, of course, is a very important assignment in regard to what you need to know on the test. But there's a lot of that on the review and, of course, on the test, so I'm not going to collect this one. So our agenda today, first you're going to complete Lab 3.2. You are to turn that in before the end of class today, so I'm collecting that today. Once you have completed it, if you want to check your work, just let me see your paper and you can do so at that time. If you are at home and you are watching this video, then I will have the key posted on the answer keys page by the time my first Chem 2 class is over. All right, so you'll be able to check it at home as well. Once you are completed with the lab and turn it in, you are then to work on the Unit 3.2. And remember, there's some stuff from 3.1 on there too. Review, which was handed out yesterday. Technically, that is due today by the end of class, but of course, I don't collect the review until the exam day, which just so happens to be Monday. If you do have it finished today, though, of course, you may check it with the key as long as you show me your paper first. You also have a Mastering Chemistry, Unit 3.2 Electron Configurations and Periodic Trends, which is due Monday morning at 7:30. All right. So just as a reminder, this coming Monday, your review assignment is to be turned in. We have an exam. Don't forget that it will also contain some material from Unit 3.1. These two units are very much related. And then you have a Mastering Chemistry assignment due at 7:30. As far as the exam review, I'm going to run a little separate video on that. So at the conclusion of this one, after you have finished the lab, you can then look at that. That has some detailed information about the exam, like I always do beforehand. So, having said all that, let's head back to the lab and do Lab 3.2. Plug here. And head back here. Set up here. Let's see how I want to do this. Like that. That looks good. All right, so let's take a look at the procedure here. We'll look at the discussion first. I can get down here a little bit so at least you can see me. So I'm looking at the pre-lab discussion here. The arrangement of elements in the periodic table is one of the most important achievements in modern chemistry. Sure is. You can say that again. Because of their electron arrangement, the physical and chemical properties, the elements change in a regular pattern as you go both across a period and down a group. We've talked about that at length in this unit. As a result, when elements close to each other in a period or group are compared, they have many of the same properties. The elements in group 2A are the alkaline earth metals. Like all members of a particular group or family, they have certain properties that change in a regular pattern as you go up or down the group. One of these properties is chemical reactivity. One method of testing a metal's reactivity is to have a solution that contains that metal react with another solution to test for the formation of a solid substance or a precipitate, as we know it. The formation of a precipitate indicates that a reaction has occurred. So in this lab, we're going to compare the reactivity of the group 2A metals by testing their ability to form precipitates. So what we have here is right here, I have 4 solutions that contain 1 metal of each of the metals in group 2A. Now, we have a magnesium solution, a calcium solution, a strontium solution, and a barium solution. I do not have a beryllium solution. Those are kind of hard to come by, and it's quite expensive. So beryllium's at the top of 2A. And then at the very bottom of 2A is radium, which is, of course, most isotopes of radium are radioactive, and they're also quite expensive. So we're not dealing with that one either. So we only have 4 out of the 6 group 2A metals, but we can certainly get a trend from those 4 and then extend it to the rest of the group. So across the top here, I've got 3 solutions that we're going to react our 4 2A solutions with. One is sodium carbonate, one is sodium sulfate, and one is potassium chromate. So here we have a well plate, and we're going to run our reactions in the well plate. We're going to put 5 drops of each of these solutions based on their location here, and then see what the reaction is. So let me put the old goggles on here. Okay, so my and you have a little, we have a little guide here so we can show what we're doing here. So basically what we're going to do is I'm going to put 5 drops, 5 drops of the magnesium solution in each of these, in 3 out of the 4 wells that run across the top here. So 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. Then I'm gonna, in the next row down, I'm gonna do calcium. So we're gonna do magnesium on top and calcium beneath it. That dropper is not working too well, so excuse me a second while I grab pipette. Here we go. That one has seen better days. All right. So now I'm in the next row down. 1, 2, 3, 4, 5, 5, 5. Okay. And then the next one down is strontium. So I'm going to put 5 drops of strontium solution in each of these in the 3rd row down. 5, 5. Okay. And then lastly, barium. 1, 2, 3, 4, 5, 5, 2, 3, 4, 5. There we go. All right. So without tipping it over, so I have 5 drops of magnesium solution right here up top, and then I have 5 drops of calcium solution in the next row down, strontium in the next row down, and barium in the last row down. So I have them in the same order, top to bottom, that those 4 appear in group 2A. Now I'm going to put 5 drops of the reacting solutions with each of those. So now I'm going to do it vertically. So the first one is sodium carbonate. So I'm going to run it down the way here. 2, 3, 4, 5. 1, 2, 5. Wow, I'm getting some precipitates here. I'll show you in a second. Okay. The next one is sodium sulfate. Run those down vertically in the next column. 5, 1, 2, 3, 4, 5. Okay. And then lastly, potassium chromate. All of these solutions initially are clear, with the exception of potassium chromate, which you can see is yellow. I want to make note of that. Okay. So now I'm going to let it sit a little minute and do a little more explaining. So we're going to observe if any reaction has occurred in each well plate by seeing if a precipitate has formed or not. So in the data table, we're going to record our results by writing either yes or no. So let me pull up the little sheet here. So as you can see on the back, we have our data table, and we can see we have down the side here are four metals from group 2A: magnesium, calcium, strontium, and barium, again in the order that they appear in the periodic table in group 2A. And then across the top here, we have our three reacting solutions: sodium carbonate, sodium sulfate, and potassium chromate. And so now we are then going to just write in the data table yes or no whether we got a precipitate formed or not. So let's take a look. Okay, so I'm going to get this as close as I can without tipping it over. There we go. Hopefully you can see that. So as I look in, so this is our magnesium row, the top one, and then our calcium row, and then our strontium row, and then our barium row. So as I look across the top at our magnesium row, we do have a precipitate right here in the first one. It's fairly weak, but it's definitely there. And then the other two, I don't see any. So across that first row in the top, I'm going to write yes, maybe a little note that it's a weak one, but it's there. And the other two are no. Now, as I look on the second row across, which is our calcium row, definitely have a precipitate in the first well. It's a much more stronger, significant one. And the other two are still a no. So in our calcium row, the second row in our data table, yes, no, no. The third row down is our strontium row. So we definitely have precipitates in the first two across there. And in the third one, we do not. So third row down, our strontium row, we are yes, yes, and no in regard to precipitates. And then if we look at the last row, which is our barium row, I see a precipitate in all three of those wells. So we have a yes, yes, yes in all three. So let me put that back up. And just to review here, all right, hopefully you can see that. We have a yes in our top row, our magnesium row. We have one yes, although it's weak. In our calcium row, we also have one yes, although it's much stronger. In our third row, our strontium row, we have two yeses. And in our last row, barium, we have all three. So it appears, initially anyway, let me get my goggles off now. It appears that barium had all three precipitates, strontium had two, calcium had one, and magnesium had one, although it was quite weak. So as we go down group 2A, it looks like the reactions increased, which means the reactivity of the metal increased. All right. So in our evaluation, we have 5 questions to answer. And all I would say, I'm going to have you answer those yourself, but let's just summarize what we saw here. So as you go down, group 2A in the periodic table, we just said that the reactivity of those metals in group 2A, according to our results here, the reactivity increases. So let's think about that. All right, so as you go down group 2A, they all end in S2. Remember, it's in the S block. Beryllium, which is at the top, ends at 2s2. Magnesium, 3s2. Calcium, 4s2. Strontium, 5s2. Barium, 6s2. And radium, 7s2. So as you go down group 2A, and we've talked about this before, as you go down any group, the electron configuration ends exactly the same, only as you go down the group, each successive row, you're in an energy level farther away from the nucleus. Well, what's happening then? As you get farther away from the nucleus, those valence electrons, in this case 2 valence electrons in 2A, are being less, and less tightly held. In other words, the Coulombic force between the nucleus and the valence electrons is weakening. All right. So if those valence electrons are not being held as tightly, then are they more likely to escape and react with another atom? And the answer, I hope you would say, is yes, they are. So as the Coulombic force of the nuclear pull for the valence electrons is weakening, then that metal is becoming more reactive, which is exactly what we saw right here. So that trend is easily explained by Coulombic force, as is all trends basically, as you go down a group. And this one is no different. All right, this one's no different. So based on our little discussion here, I need you to fill out the rest of the questions, answer those, and then, which shouldn't take you very long, and then I'll have you turn that in. So if you're here at class, you'll turn it in before the end of the period. If you're at home, you will submit it to me electronically by the end of your regularly scheduled class period. So that's going to be the end of this particular video. Like I said, I'm going to do a separate one for the review for our upcoming exam on Monday over Unit 3.2 and partly Unit 3.1. And so when you're finished with this, head to the next video and we'll talk about the exam. Okay? So until then, this is Mr. Keister signing off. Take care, everyone. Stay safe, stay focused, and I'll catch you next time. So long.